Alrighty. Hello, everyone. My name is Carlin Pounders, and I am the program coordinator for SimLink. And I will be getting us started with tonight's virtual Teen Science Cafe program. First, let me share with you some information about our organization, which is called SimLink. We provide opportunities for youth to be exposed to STEM and STEM careers. Our mission is to increase the self efficacy of K through 12 students to pursue STEM careers by introducing them to positive adult role models that increase their awareness of STEM careers and encourage their participation in STEM research through digital learning and hands on activities. Tonight's Teen Science Cafe program is a series of workshops that we offer for middle and high school students to introduce them to STEM careers. The cafes take place in informal settings where the STEM professionals share their career journey and current work with students and engage them in a hands on activity if it's in person or a demo or video to connect them to their work if it's virtual. We host cafes monthly, both virtually and in person in Metro Atlanta. Tonight, we will be hearing more about nutrition, food safety, and science communication. Our featured speaker is Dr. Tamika Sims, who is the Senior Director of Food Technology Communications at the International Food Information Council. So, without further ado, I will pass it along to Dr. Sims to get tonight's cafe started.
Thank you so much. Really excited to be with everyone today. Oops, I'm advancing a little too fast. So, my name is Tamika Sims. I am Senior Director of Food Technology Communications for an organization called the International Food Information Council, and we call it IFIC for short. IFIC is located in Washington, D.C., but I actually work remotely in Atlanta. So I'm from Atlanta. I went to college here and graduate school here. I lived in the Washington, D.C. area for a little over a decade and then moved back to Atlanta right before the pandemic. So really excited to be here today, but really glad to be able to talk to you about my work, even though the headquarters are so far away. So for the convo tonight, these are just some bullets of what I'm going to plan to cover. So how did I get on this path of loving science? Where my path started as far as learning science, and then how do I leverage the science that I love so much for career choices? And then we'll have some time for some Q&A if you guys have any questions. So for me, loving science started when I was a kid. I don't know how many of you guys like to play or make your own slime, but I love to do things like that. Little chemical reactions where I played with slime. I also like to explore in my backyard. Today I wouldn't do this because I unfortunately have a fear of bugs as an adult, but as a kid, I loved to dig into the dirt and find bugs and earthworms and just look at them operate in their environment. And I always loved animals. And for a long time, I thought animals would be what I would do when I grew up. I don't know what animals, but I love them and I love nature enough. But again, like I said, I also like things like making slime. So that's a love of two different things, right? We're loving chemistry and chemical reactions, but then also loving biological systems and ecosystems. So my love for science was all over the place. But I really thought that if I loved it, I could do something with it. And definitely that's how everyone here should feel too. Whatever you love to do, there is more than likely a way you can leverage what you love to go to college, go to grad school, have a career, whatever you choose. There's so many opportunities out there. So here are little things about me and science. I was always curious. I like to explore the unknown. Love learning new things. I'm still like that. I like to see new things happen. Some people are not crazy about new things happening around them. It can make you uncomfortable, but you can also think of learning new things as your world expanding. and making you smarter. But I also am a kind of person that I like a certain amount of predictability. So I think this is kind of where science, the reliability of science, makes me happy. There's so many things that we can rely on in scientific systems that are continuous while we are also still learning new things. That's really important. Science is always evolving and changing. We're always learning more, but there is a certain level of predictability that's associated with scientific systems as well. So this is where I went to college. I went to Spelman, that's in Atlanta here. Um, did I know I was always going to go to Spelman? No. Did I know that I was going to be a biology major when I got to Spelman? No, I did not know that either. So when I was in high school, I loved science. Like I said, I continued loving science, but I also loved art. And I was pretty good at drawing. I thought for a long time I wanted to be an animator at Walt Disney Studios. And that was what I was going to do. I was going to make, well, I'm much older than all of you guys. But animation has really changed so much over the past 20 years that it's nothing like what it used to be way back when The Little Mermaid first came out, or when Beauty and the Beast came out, or when The Lion King first came out. But I wanted to be a part of that. I love to create. So using my hands to create things, if you think about it, there's a kind of a line between art and science where using your hands to create something that no one else has ever seen can thrill you for both types of careers. So my love of science led me to apply to a pre-freshman summer science program that's offered at Spelman, and it's still offered there. Spelman and all the schools in the AUC, so Spelman, Morehouse, and Clark Atlanta University, have a summer program that is free for middle school students to apply to. That is the Verizon STEM program. So if you're interested in doing some STEM this summer, definitely get on one of these schools' websites, spelman.edu, morehouse.edu, Clark Atlanta University. Get on their websites, look up their STEM programs for the summer, because they do have things that are available to middle school students, and many of them are for free. So you have a nice summer program filled with STEM activities for free. I encourage you all to take a look at that. For college kids, like I said, or kids that are approaching college age, like if you're a junior or senior in high school, they have programs for that too. If you're thinking about something that you want to do, it doesn't have to be at Spelman or Morehouse or Clark Atlanta, but area universities, wherever you live, will offer really great summer programs for kids. So anything you're just kind of interested in, just give it a try. It's just a few weeks out of the summer, and you'll learn so much about what you want to do, and how other students just like you are thinking about what they want to do with their science, and their love of science. And some of them may not really love science, and that's okay. You don't have to love it, but if your interest is there, just see where it takes you. So from Spelman, I graduated with my bachelor's in biology, like I said, and I was a pre-med major. And the pre-med majors, it was serious. So it's a lot of work. It's a lot of tough work. And not everybody sticks with that pre-med major. They find out that the challenge in the science classes is more than they wanted to master. But sometimes people like me and a lot of other people like me stick with it. And at the same time, while you're thinking about being pre-med, that means that you're on a track to go to medical school. And Spelman was very pushy when it came to encouraging us to apply to medical school and to go. But you know what? I really realized that I wasn't sure if it was right for me. Now, I'll tell you this, the first time I had to take the MCAT, and I'm saying first time because I took it more than once, it blew my mind. It was one of the hardest exams I've ever taken in my entire life. And it made me think, like, do I really want to do this? And that happens. That's normal. But I pushed forward. And I just thought maybe I need to mature more and do a little bit more scientific work before I go off to medical school. So, what I did next was I went to Georgia State University and got my master's in biomedical sciences. When I got to Georgia State, it was totally different than Spelman. It's a much bigger school. I don't know if any of you have family or friends that went to Georgia State, maybe some of your parents. It's all so it's spread across downtown Atlanta. So it's much more spread out than the smaller community of the schools in the AUC, the Atlanta University Center, where Spelman and Morehouse and Clark Atlanta and Morris Brown are, and Morehouse School of Medicine. But it's also it gives you just a different view on what you can do with the science after you leave graduate school. Medical school doesn't have to be the only thing you do or want to do with your love of science. It can be that for me, and what I realize is that I love the science more than I like the idea of practicing medicine. And I'll explain that a little bit. Scientists spend a lot of time in laboratories. They get to do their experiments, they write their papers, they talk to more scientists, they do their experiments again. It's a very low key way to work. However, if you decide to be a doctor, you have to be a people person. Why? Because you have to see your patients every day. People come in, they need care, they need your understanding, they need your ear, and you have to perform this top level of customer service. So it's a lot of FaceTime with people every day, but it also means that your ability to practice science and perform experiments is going to be pushed aside so that you can, see your patients every day and check in on them. It's a wonderful thing to become a medical doctor. I don't want to deter anyone from that path. I think it's a fabulous path to be on, but it just wasn't for me. So even though Spelman was pushing, I realized that I wanted to do science more than I wanted to do medicine. And being at Georgia State made me realize that I loved my graduate courses here so much that it made me realize that instead of getting my MD, I wanted to get my PhD. And that's what led me to this place, Morehouse School of Medicine. So, a lot of people don't know a lot about Morehouse School of Medicine. So, it's a smaller medical school that's in Atlanta. So, it's not as popular as bigger schools in the southeast as far as medical schools go. But it's a wonderful school. They have programs for students to get their MD, be a medical doctor, PhD, like me. You can also get your master's in public health. You can get your master's in biotechnology. You can get your master's in medical cannabis therapies. They have so many programs for anything and everything you want to practice that's dealing with medicine. And the focus for a lot of the work Morehouse School of Medicine does is for health disparities. So that basically means health problems that are particularly impacting minority or BIPOC communities. Many things like heart disease, microbial illnesses that are caused by microbes, which are bacteria and viruses. I actually studied virology. And so if you never heard of that, that's the study of viruses. And so I did my graduate studies in HIV research. So a lot of you probably, of course, you've heard of HIV, but what's probably a more popular virus that everyone's heard of more recently? COVID, right? So I was pretty popular during the pandemic. A lot of people came to me with questions about what they should do, what they should not do. Everybody was really worried about what this virus was doing to everyone, this little thing that can make you so sick that nobody could see. But other programs at MSM focus on cancer, they focus on maternal health, so pregnant mother health. There's so many programs. So again, if you think you're on a path that you want to learn more about what you can do with science, definitely take a look at Morehouse School of Medicine. So msm.edu. Where I work now, I'll talk about a little bit about IFIC, but I also want to note too, I'm also adjunct faculty at Morehouse School of Medicine. So right now I teach an online course for graduate students who want to get their master's in biotechnology and for the medical cannabis therapies program. So it's all online. It's a fabulous program. Tell a friend, tell a parent. It's a great program, and it's really a great school. And so one thing I'll also note is that for me in the PhD program, my whole first year, the PhD and the MD students took all their classes together. So while you may be kind of trying to figure out what you want to do, MD, PhD, you can also have, the best of both worlds and know that your first year is going to be very similar. There's also people who get both degrees at once. They're MD, PhD. So I think maybe about 2 people in the class that I came in with did that. It's very rigorous, but very beneficial on the back end when you're thinking about what you may want to do with your career. And so you may be thinking too, like, how did you getting a master's in biomedical science and a PhD in virology lead you into food science or nutrition communications or food safety communications? Well, if you're thinking something like that, I'm glad you are, because this is where my journey is probably different than a lot of other folks that decide early on that they want to study food science. And to be quite honest with you, when I was a kid and in college, I didn't even know that kind of degree existed. I didn't know you could get a degree in food science. It didn't even occur to me. I just was following a path that I felt right to me. I like science, I'll keep going. And it still ended up being just fine. So if I'm kind of mentioning this because I think it's important for you to think about while you're in middle school, while you're in high school, while you might not have all the answers and know exactly what you want to do, just follow what you love and it'll all fall into place. Just keep pushing, do your best, and follow what you love, and it will continue to fall in place. You're young, very young, so nobody expects you to have all the answers for what career you would like to have, but definitely coming to places like the Science Cafe is a great way to kind of know what's out there. So I'm going to move on. Let's see. So my next slide. So this is the header for our website. So you see at the very top left here, International Food Information Council, nice and tiny. But if you go to ific.org, ific.org, you'll see this nice family pop up. And our mission statement here: we promote science-based information on nutrition and food safety from farm to fork. And so basically, IFIC is a science communication nonprofit organization. Now, I know I just said a mouthful. There are a lot of nonprofit organizations, meaning they are companies that do not work to produce something that is for sale. So they're not for profit. How do they make money? Where does the money come from? Well, specifically for IFIC, the money comes from membership dollars from companies. So the companies that make food and sell food support my organization. And basically, there are several different companies that support IFIC. So you may recognize a lot of these logos, and they may be representative of some of the foods that you love. So Coca-Cola, if you live in Atlanta, you gotta love Coca-Cola, right? PepsiCo, which is Pepsi as far as the drink goes, but the company itself makes a lot of snacks. You may not know that. So PepsiCo is a beverage and food company. McDonald's, everyone knows McDonald's. Mondelez is the company that makes Oreos. I know you know Oreos. Even if you don't love Oreos, you know what an Oreo is, right? General Mills, Hershey. Some of these names are very familiar because we just had Halloween, right? Mars is one of them too. Danone, North America, that company, a lot of yogurt products. They're in your dairy aisle in every grocery store. Red Bull, which is probably not something you should be drinking if you're under a certain age, but I bet you guys know what Red Bull is, even if you don't drink it, right? Kraft Heinz, you got to have ketchup for those McDonald's fries, right? So these companies make lots of different types of products. We also have members that are ingredient companies. So I didn't put their names up here because if I put them, you wouldn't know them. But they're companies that make the ingredients that go into a lot of the foods that these companies manufacture and sell and package and end up in your store or end up in your food service restaurant like McDonald's. And some of the companies that are members of IFIC work as far down in the food system as the farm. So we have members that do a lot of work for both animal and crop agriculture. And I'll talk a little bit about that when we talk about what careers look like and what IFIC does in order to support the development of information about food and food safety and so on. So I want to start with this. Well, I guess I'm not really starting. I'm in the middle here. But I wanted to bring up this picture because I wanted to see how many of you all have had experience in working in a laboratory and what stands out to you here as things that are wrong that these people are doing. So take a minute and type into the chat, what do you see as being wrong in this picture for this laboratory? Just type it into the chat for me. Okay, I'm gonna call out just a few things. I don't know how much lab experience you all have had, but one of the things that stands out first and foremost to me is that no one in this room has on any lab equipment. So if you've ever done a chemistry experiment or even just a small experiment in your classroom in middle school, I'm sure you guys had to either wear gloves or goggles, maybe even a lab coat, right? Those are things that help protect you. No one in here has that type of equipment on. Another thing that's really bad is that this woman has on open toe shoes and she's sweeping up glass. She could definitely cut herself. She could even harm someone else because the way that she's sweeping is wrong. This guy over here, he's picking up glass with another piece of glass by tilting the waste basket over to collect it. Big no-no, big no-no. These chemicals over here on the right, they're left unattended, sitting out. Big no-no. He's also using the wrong bucket, right? This says waste, this says glass. Not following instructions. This woman over here, she's putting on makeup in the lab. You're never supposed to do anything personal to your face or body in a laboratory. So a lot of red flags here on safety and practices in the laboratory, right? But this is science. This is how science starts. It starts in a lab often. But safety is a part of the foundation of successful scientific experiments. and I'll lead into this later, safety is also at the foundation of successful food production and development. Safety is also at the foundation of successful food preparation in your home. How many of you guys like to cook? Drop a smiley face in the chat if you like to cook. If you like to cook, then you know there's rules when you cook, right? Would you ever turn on the oven and then put your hand on top of the stove? Would you ever turn a burner on and put your hand on top of the stove? No way. You know it will burn you, right? Would you ever leave the water running in the sink while you're doing 10 other things and just leave it running for hours? No, you wouldn't do that either. There's so many different things that I'm sure either your parent or an older sibling or anyone in your home, or if you take a home ec course, you learn safe practices in a kitchen. And they're very similar to safe practices in a lab. So I'm kind of linking these two things together because it's good to think about food like science. There's so much that goes into making sure food is safe, and many of it is geared toward or has parallels to safe practices in a laboratory. Okay, let's do one more of these exercises. So here's another lab where people are doing some crazy things. I want you to take a moment, type into the chat a few things that you see that are wrong in this laboratory. And if you don't feel like writing it in the chat, it's okay. Just kind of collect them in your head while you're looking at it. Okay. So here's another lab scenario. Again, it's a group of people working together, but they're doing some really unsafe things. They're doing things that can harm themselves and it can harm their fellow lab mates. And once again, like I said, if you haven't been in a chemistry lab or a biology lab yet, you will one day. And so you'll know one of the first things that your professor or your instructor is going to tell you, you need to have on proper lab equipment. It's there to protect you. So one of the things I see my man here, he has on his goggles, but no gloves. Also, he's looking to smell what's in here, but he's taking a big whiff of it. That's a big no-no. You never do that. What if there's something in there that if you inhale enough of it, it can make you sick? If you want to know what something smells like, you're supposed to hold it far away from your nose with gloves on, or you may actually work in something that's called a hood. And it's like a box that you could put your hands into, and it has a fan at the top, and the fan whips around air to keep too many of the fumes from getting to you. But if you want to smell, you're supposed to put it a few inches away from you, and you just do, you move your hand over the top of it to move some of the smell towards you. And it's called wafting. That's what you're supposed to do. Okay. Same thing for Sarah here in the middle. She has on gloves. Fantastic. No goggles. She's also mixing these chemicals together simultaneously through a funnel. You should never do that. She also is doing this mixing, being within elbow's reach of her lab mates here. What if the mixture that she's doing bubbles over and spills and then it hits my man over here on the arm and it burns his skin? He doesn't have his gloves on. That kind of thing is possible. I'm sure this jumped that out at you that Andrew here is sipping whatever this is through a straw in the lab. Dangerous. First of all, lab equipment is not like food equipment. It's this because it's made of glass. It's not like a glass that you have in your pantry or in your cabinets that you can just, drink from. Also, there's never eating allowed in a lab, eating or drinking. And then we see over here, all the way to the right, there's a spill that's occurred and there's broken glass and it's just totally unattended. So it's a lot of things that ring out here that hopefully, if you've ever worked in the lab, some of this, some of these no-nos are popping out at you and you're like, oh my God, this is so unsafe. But if you haven't seen it before, just know that there are rules when it comes down to doing science to keep you safe, to be sure that the science is productive as well. If you're doing things that are haphazard and you hurt yourself or hurt someone else, all the science kind of goes down the drain. It's for nothing, okay? And that's the same thing for food science. We work to make sure that food is safe. We have to make sure that food is accessible. We have to make sure that people know how to handle their food. We have to also make sure that people understand their food, because a lot of times you may be looking for some type of nutritional benefits, but you don't know a lot about the food. And so this is definitely where if it comes in. So I kind of want to call out some things here that show the parallel between working in a lab, which you guys all may, know a little bit about because of time at school, or running your own experiments, maybe in a summer program, something like that, and bringing it into food science, which you may know just a little less about, and why I'm here, right? So, use of lab equipment, definitely something that is present here in this picture and is important in food production, and I'll talk more about that. Chemical reactions and safety. Like I said, look at what Sarah is doing here. I mean, how do we not know that this is going to combust? And you can see that she's smiling really hard. That kind of tells me she doesn't know what's going to happen next, but she can't wait to find out. And it's scary. So, chemical reactions and safety. This is important in food science too. Teamwork. Both pictures I showed you show groups of people working in a facility or a room together. When you're thinking about the food system, or you're thinking about a laboratory, we're all working as a team to make sure we get good results. We want the results of the science to somehow help humanity and help mankind, right? So that starts with the people who work with you. So teamwork. Hazard analysis. What's dangerous in this room? What's dangerous to me or the people working around me? But then what could potentially be dangerous for any final products that I have? Okay. So hazard analysis, that happens at every level and every type of science. Got to know what's dangerous. And then final product testing. My man here is drinking it. That's not how you test the final product. But final product testing is something that happens a lot in food science. Eventually, of course, taste tests are done in food production, but you get a long way down the food production chain before you start tasting it. It definitely doesn't happen at the lab level, okay? So I'm going to move on. So now I'm jumping into branches of food science, and I got this little cute tree here. And it's basically showing you different types of food science related employment or career path opportunities. I'll put it that way. It's more like a career path. And I think that's how you should see it. It's a path. It can change direction. It may, ask you to go backwards a little bit and rethink something you've done. It is a path. Okay. Here they're using this tree analogy, but I like this too, so I used it here in my slides. So food production, like I said, begins with understanding scientific fundamentals. This was the point in me showing you just some basic lab practices, something that like I said, if you haven't encountered it yet in school, you definitely will. And you're going to learn. Safety is like one of the top things or first things your instructor is going to teach you. But it will carry and mean a lot to you your entire life. So food safety understanding is linked to chemistry and biology principles. So just like I was saying, we saw a lot of chemical reactions in that last slide, but biology principles Those are my babies. I love biology, like I said. So I got my bachelor's in biology. Always loved biology. I like to study life, which is why I probably love bugs so much when I was little. Not anymore. But biology is really what led the love of biology is really what led me to study microbiology. I love learning about bacteria. They're amazing little things. It's amazing to me that something so tiny can make someone so sick, but have an operating system that is almost foolproof when it needs to figure out how to multiply, how it figures out how to transfer itself from one host to another. It's all very interesting to me. I love it. But then also analytic abilities. So you liking to analyze things will take you so far in many different careers. If you like to turn, occurrences upside down and figure out how it happened, figure out how it can happen again, figure out how to not make mistakes or repeat, results that you got the first time you did something. All of that is about you being analytic. And that's a great quality to have in pretty much any career path you take. But my analytic ability in science is really why I've been able to do so many different things that are steps and steps away from what I studied while I was getting my graduate degree or even my bachelor's degree. So I just wanted to point that out. So if you like looking at things and how they work, that can take you far. So let's look at our tree over here and see some of these things that are mentioned. I wonder how many of these look like something you've heard of before. Well, food safety, we know. I keep saying that food safety. So the two purple ones, food safety and food analysis. So those are things basically you're looking at, like I said, being analytic, you're learning what the food needs in order to be safe, in order to be packaged and delivered to a consumer, a person, and that's all of us. Food toxicology. I gotta tell you, I would be remiss if I didn't tell or encourage all of you to look into a career linked to toxicology. Why am I saying this? Because toxicologists are in super duper high demand, and you will always get a job because there's not many of them. And toxicologists test the safety of so many things. It's related to food, it's related to chemicals, it's related to chemicals that are used for cosmetics. It's cosmetics like makeup, lotion, shampoo, laundry detergent. Think about so many things that funnel into or come to your home, and they have to be safe for you to be on your body or in your body. Toxicologists. Packaging technology. Yes, there's technology that goes into packaging. So I'm drinking a bottled water. I learned a lot about packaging technology when I entered the realm of the food and beverage space. People look to figure out how they can fit these bottles into a shrink wrap. You see 6 bottles shrunk together, how they can fit them so that they are stable enough to be stacked on top of each other. How much plastic is needed in order for the integrity, like the shape of the bottle, to stay the same once you drink all the water out of it? What diameter the cap can be. I mean, there's so many different things that go into understanding the shape and dimensions of a bottle that you would never think of before. But it's fun to try to figure out new ways in order to create packaging efficiency. So I'm not going to go through all of these, but I wanted you to be able to take a look. If you love cereal, you may want to go into cereal science. If you love to bake, you may want to go into bakery science. There's so many different things you can look at when it comes down to careers in food science. Okay, so now I'm going to kind of pull it back into what I do and what my team at IFIC does in order to talk about food production and food safety and science and nutrition and everything related to your food. So the team that I work on is focused on production and safety. But we have people who work on nutrition issues at IFIC as well, and they are registered dietitians. So these are people who go to school specifically to be able to give scientific based advice on what you should eat in order to be healthy. And of course, there's many different ways to eat in order to be healthy. But what do you know about the food? What would you like to know in order for you to make the healthy choice? So there's a lot to think about there. But I'll go back into this and it feeds, so this diagram basically feeds into different areas of the food system that we touch in order to develop communication resources. And I'm going to, at the end, I'll show you the website where you all can go to read more about um, food systems and safety if you would like to. But then also learn about different types of diets and things that people like to eat and the health benefits you can get from some of the things you like to enjoy as well. So let's start here at production. So for me, I talk a lot about production in different types of ways. I'm talking about what happens on the farm for crops and animals. But you know what that means? I have to talk a lot about and know about chemical inputs. What are the chemical inputs that you think are used on a farm? If you want to type it in the chat, you can. But it's pesticides, right? Farmers have to use pesticides, which are chemicals that either work to deter bugs and insects or to kill them if they consume the fruits and vegetables in the field. So you want to keep them away, right? I don't know how many of you, your parents may have a garden, but a garden is a lot of work to keep up. Why? Because there are bugs that come and munch on all the leaves. There's things underground too that can munch on whatever's growing under there. And you're trying to grow the food, but you cannot do it without because of the pests that are there. GMOs, I just did a talk earlier this week with some kids about GMOs. People don't know a lot about GMOs, but it sounds scary, but it absolutely is not. I definitely would invite you to go to foodinsight.org and learn more about GMOs if it's something you want to learn and just understand more about. But a GMO is just a crop that basically has been changed on a DNA level in order for the crop to grow more efficiently. It's there to help the farmer and to help us. So productivity in farming is a really tough business. You probably hear a lot of things or may have heard a few things at least about climate change. And what climate change is doing, it changes our weather patterns in unpredictable ways. Weather predictability is something that farmers use a lot in order to ensure that the food is able to grow, right? So GMOs help a lot with that in the food system. And not everything has a GMO counterpart, but there's a lot of crops that are used heavily in our food system to for food ingredients that are GMOs, and they're safe. There's over 30 years worth of science that shows that GMOs are safe. So I won't go too far down the GMO track, but just wanted to call that out. And farming technology, helping farmers monitor their fields and monitor their animals in order to make sure that productivity stays at a certain level. So another thing I do cover too is trade harmonization and sustainability. So I'm not going to talk too much about that, but a lot of the food that we produce in our country gets traded and sent to other countries and vice versa. So there's rules in different countries about how the food can be grown, what can be used in order for it to be treated for, pesticides or anything else in order for it to be traded from one country to the next. So that's basically what trade harmonization is. So food is then transformed, and then this is basically food processing. So food processing, I'll click twice. Food processing is and ingredient safety are basically understanding what happens in a facility when you take the raw product, or what came out of the field, and transform it into the final product that is bought in the store. There's a lot there. This is probably I couldn't even do it justice just talking to you guys in 30 minutes about what food processing really looks like. But it's really a lot of fun. If you think about chemistry, like we saw, the girl pouring the two chemicals together, it's not exactly like that, but there are processes in order for food processing to be safe. But think about this. If you like ice cream starts where? On the farm, right? With a cow, right? Cow makes milk. The milk then has to be processed for safety. It needs ingredients added to it, like sugar and maybe some flavoring and maybe some other things to give it the right creamy texture that we all love. And then it's put into containers, and then it's shipped to a store, a grocery store or market, or even a restaurant, right? So it is a lot of steps in making sure food reaches us in our stores and in our restaurants. But a big chunk of it is related to food processing and ingredient use and safety. And then finally, I wanted to call out foodborne illness and packaging integrity. So I talked a little bit about packaging. And full disclosure, I used to work at a different nonprofit organization that represented the bottled water industry. And so that's why I learned a lot about plastic bottles and water and beverages. But it made me realize how important the work that those companies do in order to help us have safe and reliable products over and over again, and working on packaging integrity, but then also thinking about sustainability. So I didn't put it up here, but these two things at the end here show trash and compost disposal. It really should have another arrow showing recycling. So a lot of packaging, not just plastic, of course, paper, glass, aluminum, food packaging needs to be recycled. It's good for the planet, it's good for the food system, and it helps us reserve natural resources quite often. So, lastly, foodborne illness. So, foodborne illness, I don't know how many of you guys have ever had quote unquote food poisoning, where you got pretty sick from something you ate. You had no idea what it was, or sometimes you may have known what it was, and you're like, oh, I shouldn't have had that. Whatever, whatever the thing may be. Foodborne illness oftentimes is not necessarily the fault of the food production company. It can be at the fault of the consumer or the person who's handling the food. So if you get food at a restaurant that, bad, somehow it made you sick, it could have been that the person preparing the food either didn't store the components of your meal correctly, or they didn't cook them correctly. And so that can make you sick. But this is the same types of rules you need to follow in your home. You have to store food properly. You have to cook it properly in order to be sure that it doesn't make you sick. So foodborne illness is something that's very serious. And at IFIC, we talk quite a bit about the Centers for Disease Control and Prevention, the CDC, also in Atlanta, and the statistics they pull on how often foodborne illness makes people very sick. And sometimes if you have a weak immune system, it can be quite serious and very scary. So these are all the parts of the food system in a, kind of lengthy nutshell. But I wanted to be sure to kind of point out some of the things that I cover while I do my work at IFIC, and how I've gotten into this place. So while I'm a scientist, a lot of this is a long way from virology, but a lot of it isn't. Definitely knowing about biology and chemistry at a different type of level feeds into all these things I have listed here for you. And so that's why I am where I am. So I have a short video. Hopefully this will work. And try to turn the volume up on your computer so you can hear it. It's only 6 minutes.
By far, the most common question I get asked is, what's food science? But after that, the follow-up question is always, where do food scientists get jobs? So today I thought I would go into more detail about 3 different sectors of the food industry that a food science graduate might find themselves working in. All right, the first sector I want to start with is food manufacturing because I think this is the most obvious area of the food industry. And what I mean by food manufacturers are they are the people or the companies that make the products for consumers to sell directly to consumers. The foods you see in the grocery store or in stores like Costco and Sam's Club. And often these are really iconic brands, at least the very large food manufacturers. Companies like Hershey, General Mills, Kellogg's, Mars Wrigley, Kraft, Heinz. These are brands people are very, very familiar with and are used to seeing in stores. But that doesn't mean that there's only these giants playing in the food manufacturing space. There's actually plenty of mid-sized and startups or small companies. Where I went to school, there was a lot of mid-sized companies that made cheese, for example. You may have heard of brands like Sartori's, Argento. Those are sort of mid-sized companies. Whereas the small companies, often these are startups. So something like Impossible Foods or Beyond Meat, those are really good examples of some of the smaller companies that would still need food scientists. All right, let's move on to the second sector of the food industry I want to talk about, and that's ingredient companies or ingredient manufacturers. And these are companies that act sort of behind the scenes. You probably won't recognize their names because they only make one component of the food product. They don't manufacture the final food product that you would see in the grocery store. And a great example of this is the first internship I had in the food industry. This was at a company, they're called Dairy Concepts. And you've probably never heard of them because they produce cheese powder, but they then ship this cheese powder to their customers. It might be used in something like boxed mac and cheese, or it might be sprayed onto a chip like Doritos or maybe Cheetos. It's just they only make the cheese powder. They don't make the final chip or Cheeto, right? And so these guys, these companies, they're really kind of underappreciated because their name is not on the final product because really they just provide one ingredient. There's actually a lot of these ingredient manufacturers because they can be very specialized. One manufacturer might only provide different oils, or they might sort of specialize in starches or flours from different grains. And again, they just provide these to a food manufacturer, and it's that food manufacturer that you typically see on a label of a food product because they're the ones that really put together the final product and assemble all these different ingredients into a food product. There are a couple big names for ingredient companies. I think the ones that are most well known are probably Cargill, Tate and Lyle, ADM is another one. There's a few other big players, but a lot of these companies are quite specialized and maybe smaller. All right, the final area I want to talk about is food service. And this, I think, is less obvious to people that food scientists will have to work for food service industry. And what I mean by food service could be if you have cafeterias at your workplace, cafeterias in schools and universities, they don't make, their food from scratch. They are getting it from somewhere. And food service also includes a lot of quick service restaurants. Starbucks is a good example, Panera Bread, McDonald's, Wendy's, Chick-fil-A. All these restaurants, they aren't producing their food from scratch, right? At Panera Bread, they are getting, a big container of a soup already assembled and probably just throwing that in a heater to warm it up. They're not chopping up each of these individual ingredients and making their own soup. Food scientists that work in the food service sector, they're responsible for things like new product launches. Maybe they need to launch a new chicken sandwich. Maybe they're going to formulate a new sauce, that type of thing. And they also would probably be responsible for helping with menu development for these restaurants or cafeterias. There also would probably be a big emphasis on food safety and food quality because, again, they are handing this food off to another restaurant or institution to prepare. So they have to think, how can we make sure this food is safe even once we give it to the next restaurant and they are the ones that prepare it. Awesome. I think that just about wraps everything up. I hope this was helpful, especially if you're thinking about majoring in food science or going into the food industry. But I would super appreciate it.
Okay, and I'm running short on time, so I'm going to be quick and get through these last couple of slides. So I am just putting this up here for some resources. I know that I'm happy to share a copy of my slides to be distributed to you all. But definitely come visit us at foodinsight.org. But these are also some more resources to learn about careers in food science. So this IFT website, if you go to IFT.org and just type in careers, you'll get to this page eventually. And I also like this website, Discover Data Science. They have a lot of resources about going to college or graduate school and some opportunities for scholarships, which I know is always interesting. Okay, so now I guess we have like a minute left. If anybody has questions, they can drop them into the chat. I can stay a couple minutes longer if it's allowed, but I'll stop sharing my screen. Thank you so much.
All righty. Wow, what a wonderful presentation. I feel like it is very representative of our mission, which is to unveil these different areas of STEM that youth can go into. And if they've watched this and they see something that piques their interest, then they've activated, that aspect of going for it, fulfilling their potential. So, my first question for you with today, there's so many questions I could ask, but I think something that was really interesting for teens to take away is that there's this transferable interdisciplinary aspect of STEM. If they choose, they can go down one path like the MD path, or there are other aspects of STEM where it can look like different things. And so, early on in your presentation, you did touch on with today, I'm asking this because today is actually National STEM/STEAM Day.
Oh, yeah,
And early on in your presentation, you touched on arts and STEM. And so, I was curious if you could talk any more about how the two can come together for teens.
Yeah, no, that's a really good thought and question. Yeah, I think that it's very true that once you go to college, whatever you choose to major in doesn't have to dictate what you finally do. So if you are going to college and you say, you know what, I'm going to major in art. I want to do it. I don't know what I'm going to do with that next, but I'm going to do it. I think that's what you should do. A lot of times you don't have all the answers when you're only 17 years old. That makes sense, right? So it can be that what you learn in college can make you want to change your major. That happens. But it can also help you mature enough in one discipline to figure out if you want to stick with it or figure out if you want to change what you would like to do. So I would definitely suggest, if there's a type of career that you would like to have and you don't know a lot about it. I don't know how many of you guys have a LinkedIn account. You probably don't. That's where all the old people like me are. But the wonderful thing about LinkedIn is that you can look up anybody's profession. I have literally been watching a movie and put a person's name in LinkedIn that I saw in the credits and went to their LinkedIn page to learn what they did. Where did they go to school? How did they learn to do this? How did they learn to make a Pixar movie? I just looked it up. It's so easy to figure out what pathways you can try in order to, get to where you think you might want to go and see what that person did. Look at their education history. They went to Cornell. What do they have at Cornell? I don't know. I can look it up. So I think just kind of being nosy about things like that is a great way to kind of, launch yourself into a career. But then also, like I said, knowing that what you decide to go to college for doesn't have to be the end all be all. You can decide that and then you can change it and you can do something else in grad school. I am pushing for grad school.
Right. And so I guess like my last question would be, with the different institutions that you matriculated through and the various experiences that you've had, what would you say has been the biggest skill that has been helpful with getting you to where you are? I know you have mentioned analytical skills being pretty helpful to you, but was there any other ones that teens can take away from?
Yeah, I think talking to people is what helped me the most, at every stage of school. Like having conversations with teachers when I was in high school. And even in after high school, having conversations with professors. I think a lot of times it can be intimidating to have a sit down chat with a teacher, but you'd be surprised. So many of them would love to be able to talk to you if you come to them and say, I want to learn more about what it means to be a chemist, or I want to learn more about what it means to write code. What does that mean for me? What can I do with that? And if they don't know the answer, more than likely they're going to tell you who to go to get the answers. They're going to direct you. So being very open to asking for advice is something that has served me so much in so many ways, more than I can say. I'm thankful for all the people that I've come in contact with. A friend actually encouraged me to get my PhD. And I was like, huh? What's that? I don't want that. Like, I had no clue what I could do. But talking to a friend and then talking to another person and then talking to professors, and I just kept going, asking more questions, trying to get more information. It's definitely very helpful.
Well, with that being said, I want to thank you so much, Dr. Sims, for sharing with teens tonight about food safety in the lab in general, which I think is like such a great takeaway because no matter what path they go, that will be very helpful for them to know. And then also sharing with us about STEM careers in the food system. It was so vast and wide. So there's a lot of opportunity for teens who heard you tonight and uh, identified with something that sparked something in them that they want to pursue.
Yes. Thank you so much. I appreciate the opportunity to be here and to talk with everyone. And yeah, I hope that it was helpful. So thank you for having me.
Yes, of course. And to wrap us up, I also want to say thank you for the teens that tuned in tonight. Uh, our virtual cafes usually kick us off for our STEM programs for the month. And so, if you are a teen who resides in Metro Atlanta, then definitely look and see what else we have coming up for the month of November. We have a lot of in-person activities, which is why I said for Metro Atlanta youth. But each month we offer virtual and in-person programs for youth to explore STEM careers. And my very last note is that whether you tuned in live or even if you're watching the replay of this cafe, there is a survey that we would really appreciate you filling out. We would love to hear your thoughts. And, these surveys help us to continue this great work. So, with that being said, that's all from us over here at SimLink. You all have a great rest of your evening.
Thanks so much. See you.
Okay, I gotta end the broadcast. Give me a second. What happened? Ugh. No, I didn't end it. Okay, something happened. All right, I'm just gonna take us out until I can figure it out. All right.